So we're solving systems by matrices, and this is a really easy method if you know what you're doing. You have the steps over here to follow, and in the end I will show you how to read the answers, but it only works if your system is in standard form. And the standard form is x, y, and if you have a third variable, z, and then you have a constant right here on this side, constant or a number. This is standard form. So the first equation right here is already in standard form, so there's nothing I need to do to the first equation to put it in standard form. So I'm just going to copy that down, because I'm going to rewrite the whole system in standard form. Now the second equation, z is out of place. Z needs to be lined up with the other z right here. So I'm going to add 3z to both sides. Now that leaves me 0 right here. So that's my constant. For the third equation, x is where it needs to be. Y, I need to minus 4y on both sides. I need to minus 5z on both sides. And this 1 needs to go to the other side, equals the constant, so plus 1 on this. You can choose to have the plus here or not. So now I have the whole system in standard form. The system is not ready to be put in the calculator. So we're going to use matrices as a 3x4. So you go second matrix, go edit. And then I'm going to set it up a 3x4. So now I'm going to plug in the coefficients. So the coefficient is the number that goes in front of the variable. So 1, 2, 1, 9 is the constant, 2, 1, 3, 0, and so on. Now that I have that data uploaded on matrix 1, I need to get out of there by doing second quit. So I can get out of the screen, go back to the main screen, and then I need to go, so it's going to calculate that for me. So I go second matrix, go over to the side where it says math, right there, and then I go until I find RF, right there, RF. Push enter, and I need to do RF of matrix A. So second matrix, that's A, so you select that one by pushing enter, and then you push enter. So this is the same thing as you have on the steps right there. The way you read this, the first one is x, and x equals 2. The second one, where you have 1, that's y, y equals 5. The third one is z, z equals -3. And that's what we have right here, the way for you to read. So your solution is x equals 2, y equals 5, z equals -3. If you leave the answer like this, that doesn't mean anything. If you don't know how to pull the answer out of this information, that doesn't do you any good. So using matrices is just an easy way to use technology to solve systems of equations. But you need to make sure that you have a 1 right here to give you the value. So that means x is 2, y is 5, and z is -3. So x is 2, y is 5, z is -3. If you want the answer as a coordinate, 2, 5, -3. I'll take either way. Now you will have some special cases where you have two lines. If you were to graph, the two lines would be the same. One would overlap the other, or you would have parallel lines, so no solution. And what you need to look for is that third row right there. So if you have all zeros for the third row, that means they're the same lines. If the lines are the same, they intersect at every single point. And when they intersect at every single point, the solution is infinite number of solutions because the lines are the same. Now, if you have 3 zeros and a 1 right there, then the lines are parallel. That means they never intersect, therefore the answer is no solution. So here are the two special cases. Make sure you look for them, for the 0 right there and the 1 right there with that last row.